and this is my video representation for Task 7.1p, which is an account management system that allows users to add new accounts, make deposits and withdrawal, transfer money between accounts, and view transaction history. The program is made up of several key classes. The first one is an account class that holds the name and balance, for which we create an account. A bank class that manages all the accounts and the transactions, and three transaction classes: the deposit transaction class, withdraw transaction class, and transfer transaction class that perform their specific functions. All these three transaction classes inherit from a single base class that is an abstract transaction class. This abstract base class defines shared behavior such as executing, rollback, and printing transactions. This structure allows to avoid code duplicacy. The bank class includes a method called execute transaction, which takes any transaction object and execute it. It also This class also maintains a history of all the executed transactions and allows to print them. The user interacts with the system through a simple text-based menu, which is in our program.cs file. From here, the program handles the input, finds the correct account, and uses it to perform the transactions. Like here, if we try to add an account, and we have to fill our opening balance, so it is 500. Now, if we like to deposit some amount in it, we have to tell the account name in which we want to deposit, specify the amount that we want to deposit, and it has been deposited. And now if we want to check whether it was deposited or not, we can check transaction history. And here we can see that a deposit of 1000 to Ratish account was succeeded. So in this way, our program works. And principles in object-oriented programming: abstraction, encapsulation, inheritance, and polymorphism. Now I'll explain what these principles are and how I implemented them in my code. The first principle is abstraction. Abstraction is about simplifying things by focusing only on what's important and hiding the unnecessary details. In my project, I used the abstraction through the transaction class. The transaction class is an abstract class that acts as a blueprint for all other types of transactions like deposit, withdrawal, and transfer. It says that every transactions need to be able to execute, rollback, and print itself, but it doesn't explain how. The actual details are left to the specific transaction classes. That way, the rest of the system doesn't have to worry about how each transaction works. It just knows it can call the same methods on all of them. The next one is encapsulation. Encapsulation is about protecting the data inside the class and only letting it be changed in safe ways. The best example of this in the account class. Here we can see that the balance and the name fields are private, and these can't be changed directly from outside the class. Instead of changing them directly, I have provided here the methods like deposit and withdraw to safely change them by keeping in mind that the value should be remaining natural so that the account balance doesn't go to negative, or no one can make a negative deposit in an account. This helps to make sure that the account always stay in a valid state. The third one is inheritance. Inheritance is a way to share code between classes. As we can see that the transaction class is the abstract class and acts as a parent class for all the other deposit transaction, withdraw transaction, and transfer transaction classes. The transfers, all these classes automatically get the share fields like underscore amount and methods like execute and rollback from the parent class. This saves times and avoid repetition of code and make the system easier to update. If I ever want to add a new type of transaction, I can simply add that in the transaction.cs. I can simply add that and all the features of the transaction.cs can be added to it. The last and the most important principle is polymorphism. Polymorphism lets different types of objects to be treated in the same way, even if they behave differently. An example of this is in the bank class. Here, it has a method called execute transaction. Take any type of transaction that could be deposit, withdraw, or transfer. The bank doesn't need to know what kind of transaction it is. It just simply calls execute or print, and correct version of the method runs depending on the type of transaction requested. This makes the system super flexible. If I want to add a new kind of transaction later, I don't have to change how the bank handles it. I just have to create a new class that inherits from the transaction and override the methods.